Hi, in today's session, we will cover the operations and expressions. So let's go direct operations and expressions. I will add a text file here to label the operations and expressions. I will change the name as well on my file. Move this one up. Okay, so what are the operations? We have the normal math operations, that is addition, subtraction, multiplication, okay, division, and the quotient value. We have the modulus, and we have the power. So let us look to these examples here. So if I said, for example, x that is equal to 13, and y that is equal to 5, and z that is equal to, suppose that I would like to say that is equal to 3. Okay, so now let us print just to display these operations. So say I can say x plus y. Okay, so here it will do a normal addition. Okay, of course you can display it in take it in a variable, and after that you can display the values. Okay, so here this is a normal math operation which we have, minus, and this one is division, and this one is the multiplication. Okay, suppose that I would like to times y times z or that, and okay, now if I run this one, okay, as you can see here, okay, so this, the adding values, then subtract, and then normal division, and then the multiplication. Now what if I would like, of course the values here is still in memory so that I can use them. Okay, so let me do here print. I would like to print what I would like to print these values. Okay, I will just copy it here for the screen purpose, and now say for example 3 times or to the power 2. Okay, I can also say that I want to print say for example y to the power of z. Okay, so let us run. As you can see, 3 square is 9, and 5 to the power z, and z is 3. 5 to the power 3 is equal to 125. Another thing is important to just observe here. If I said I want to print, I want to print what? I want to print x divided by 5, and I want to print that is x quotient y. Okay, so let me change actually this value into y. Okay, so let us see, this one give me the fractional value, so a single slash, or this is the normal division, as you can see with a decimal point. This one is quotient, and as you can see in the quotient we have the integral value only. Okay, so there is no fractional point. Now we have another value or operation that is very important, print x modulus y. What is x modulus y? Okay, means that the remainder, if I said for example here 13 divided by 5, it's equal to 2, and the remainder is 3. If I said 13 divided by z, that is 3, is equal to 4. 4 times 3, 12, minus from 13, its remainder is 1, as we can see here. Okay. Okay, so these are examples of the normal operations which we have. Let us see some examples about this. So if I said, for example, for example, write a program that read item price and how many items the user want to buy, calculate the total bill, and display proper message. So this is our program here that we want to do. Okay, so simply as we can see here, we went first to read the price. So we write the price that is equal to, it's better to be float. And here we will have input, and then we'll ask the system enter the item price. We'll ask the user to enter the price. Now we'll do the same thing here, the items or number of items. So we can see a number that is equal to, and the number here, the user will enter 3, 4, 9, 10, so integral value. Okay, when he input, and again our message will ask the user enter the number of items, as we can see here. So bill amount that is equal to, here I will remove this one actually to price only, so I can use capital letter. So here it will be price, okay, times the number. Then again we'll print the total bill amount, as we can see here. Okay, now this is actually a multiplication operations, but now we use a full script program. So suppose that the item price was 20 dirham, for example, and I want to see 3 items. So as you can see here, the total amount is 60.0, and as you can see here, it gives me decimal point with 0 because the value here is a float value. Okay, so this is an example. Suppose that, let me rerun this, and let us say that 20.73421, and now the price, I need 3 items. So you can see that we have how many values after the decimal point, and in some cases you will have 2 long values. Okay, say for example, if I said print, say just an example here, 100 divided by 3, you see here the output has too many decimal points. Can we actually handle this? Yes, we can handle this if I will write the same program. So here I can replace the variable, open brackets, then colon dot, then how many decimal points, say 2 decimal points as a float value. So here we will do dot format, and in this case open brackets and close the brackets, as we can see here. Now what I did here, I control the decimal point for this one. I want to keep only, say, 2 decimal points. So in this case, I kept 2. I can keep 3, of course. What the system will do will round the values here to the 2 decimal point or 3 decimal point, exactly as I want. So it's rounding. So let us run here, and the value is 3. The price, this is the price, and I need 9 items. So as you can see here, 311. As you can see here, we have 2 decimal points that we got. Okay. Okay. Now, what if we would like to cover another point here? It's very important. It's called the incremental. Okay. So incremental, or the incremental value. So here, if you remember before, we said about the x and y values. Okay, so let us take the same values here, x and y. Okay, so now here, if I said I need x plus equal to, or I need y, okay, so what this x plus equal to? It's exactly as x equal to x value plus 2. So it's already incremental. What does it mean? The x has 13. So what I need to increment or add 2 to x value. Okay, so in this case, we can write x equal to its value, that is x plus 2. Okay, so instead of using this form, Python give us actually another method. We can just remove this x here. We don't need it because we will add to the same value or the same variable, and we will move this actually before plus. So simple like this. This is the incremental case. Okay, so what we did here, we can just print now. I can print the x value. Okay, so let me stop this one here. Okay, or comment it. So as you can see, it becomes 15. Okay, so can I do the same thing for multiplication, division, everything? So I can see x plus equal to y. Okay, so what will happen here? This exactly as I would like to add y to x. Okay, so let me print here x. Okay, so as you can see 20. Why is 20? Because y has 5 and the x value in the last operation reached to 15. 15 plus 5 equal to 20. So simple like this. This is called incremental. What about decremental? Decremental. Okay, decremental is the opposite. So I can see x minus 10, for example. Okay, or x minus, let us say x minus 8. X minus 8. Let us run now. X minus equal to 8. This is decremental form. So I can print x value now. It will give me 12, as we can see, because if we deducted 8 from the variable x that has 20, now it becomes 12. Okay, so this is the operations and expressions all here. The last thing that I think it's important to write a right expression. Okay, so let us see here. If I said w, that is equal to x plus y divided by 2 or 3 times z. Okay, so now can we print? We can print the w value. Okay, what we have here, this one here is called expression. So this one here is called expression. Okay, so this line of code here is called expression. What is inside this expression? It's an operation. We have plus, we have division, and we have multiplication. And of course, for the priority of operations, the power comes first, then brackets, then times and division left to right, plus and minus left to right. Okay, so this one here, left to right. Okay, and this one also here, it's left to right. Okay, so as you can see here, we will divide first, and output from division we will times, complete times, and last operation here will be the addition. Okay, so what we have here is called expression, and this is the output or display of the expression, and this is the priority of the operation. Square or the power first, the power, then brackets, okay, then times and division left to right, and then plus and minus left to right. Thank you, and see you on the next session.